Hello everyone, my name is Brendon Geils. I'm the founder of Athena Intelligence. Today I'm going to review a bit more about what Athena is, what decision intelligence is. This is going to be part one of a two-part series. In part one, we're going to review the platform, specifically our data connecting process, as well as our data modeling process. We're going to go through some questions that we get asked, which customers we serve, which problems we're solving for. And then in part two, we'll go through more of the solutions on answering those questions and diving a bit deeper into some of our user interfaces on the analyst side. Our mission at Athena is to modernize organizational decision-making with technology that empowers teams to intelligently turn data into decisions. As our website states, it's potentially a lot of jargon, so we're going to jump into the platform itself and see what that looks like. So as we log in, we're going to be immediately taken to the data connection page. On the left-hand side, we can see our navigation, including the models that we're going to be reviewing today, our decision apps, and then some of the management capabilities. If you're an admin at your organization, you're going to see the following page when you're connecting data. And then for any users, it'll look slightly different, just to make sure you don't remove any data from the platform by accident. In the cases where our customers have already normalized canonical tables, we connect directly to their warehouses, such as Redshift, Snowflake, BigQuery, Postgres, etc. In cases where you have local files or you want to do a quick analysis, we allow for CSV and Excel uploads directly. And then in cases where maybe you haven't actually integrated some source system that you're using to a data warehouse, but it's particularly interesting for analysis, we have a number of integrators that connect directly into those source systems, allowing you to answer some of those key business questions without actually having to do the integration work yourself. So I'll briefly scroll through. A lot of these integrations come from either marketing, order management, ERP, customer service ticketing systems, as well as support and social. Once you've connected your data and it's pulled into the Athena platform, we're going to go into our next setup here, which is going to be the modeling section. There's a number of different models we have out of the box, depending on the industry you come from. You can use these as a starting block, or you can build a model from scratch based on the specifics of your data. Let's take a look at a supplier model here. Before we dive in, I want to quickly orient ourselves. This is a specific modeling approach that we've taken, which is causal graphical modeling. What that is any one of these nodes you could think of as a field in a data set, and these arrows are the impact drivers of any one of those nodes. So if we take a look at this graph here, we can see delays in days as one of our key nodes. One of the core questions this customer is asking is how various suppliers are performing in terms of the purchase orders that they're being submitted. So for any given purchase order, we can think of that as a row. You would expect there to be an estimated delivery time, a shipping method for that purchase order, a destination warehouse, a supplier they've chosen, that supplier's country, all item characteristics of the PO, as well as what was the consumer price index or CPI when that PO was placed. And any one of these could be contributing factors to some of our key metrics of interest, including delays. The graph that we're looking at here, it was actually created both through a causal discovery algorithm as well as human intervention. So what that means is these are going to be coming in as single nodes. So you upload a data set or you connect your data set from a source system. The algorithm is going to actually go in and draw these causal relationships. It'll do its best. And then a human typically comes in, a domain expert, and helps refine some of these relationships and says, which direction is the correct direction, or it's potentially missing, or let's say remove one of the arrows. This is one of the kind of one-time setup costs in order to see a lot of the downstream benefits A few of those that I can call out directly right now is root cause analysis. So a lot of teams are obviously interested in prediction. So can we predict, given all these inputs, the amount of delay? But another question we can ask through these causal graphs is not only predicting the delay, but once we've seen a delay, so it's a historical PO, what was the root cause of that? Was it just because it was shipping from a long distance, or was it actually the supplier or the item that we selected, or maybe it was the destination warehouse we selected was having a particular bad day? These questions, which are typically much harder to answer with traditional approaches, are very easily answerable using this causal graph. I'm going to walk through a couple of the mechanisms for folks that aren't familiar with maybe a typical supply chain, and then we're going to talk through some of the questions that we can now answer or that we hear typically from these types of customers. So in this example, obviously delays are of particular interest, but so are a few of the other nodes, including the supplier. We might ask ourselves, for a particular supplier, where do we see the most delays for them? So is it when they're going certain distances or shipping distances that are a particular length, or is it particular items that they struggle to actually ship? And then when we do see those items through that supplier being particularly difficult, is that due to the actual amount of items that they're looking to move? Is it the volume of those items, the weight, or are they expensive items that need further handling, and so on and so forth? So another question that we'll see on here on the left-hand side is picking the right shipment method. So if we have a destination warehouse in mind, we know all the details about the item of interest that we're looking to purchase, and we're looking to actually move that forward through a particular supplier. We can actually run scenario analysis through various shipping methods and say, what would our expected delay be and expected delivery time be for air or ground or by sea? And with each of these, we can actually, in part 2, recognize not only the expected delay, but also the variance in that delay or confidence interval. So this helps us identify not only, is it going to be a 10-day delay, or we're not expecting no delay, but is that no delay actually with some tight bounds with maybe plus or minus 1 day, whereas maybe a delay of a day early with like extremely large bounds, maybe plus or minus 10 days, is not as good as a delay that's actually maybe 1 day but plus or minus 1 day. So actually seeing that in the platform as you choose either shipping method A, B, or C is quite helpful. And we can actually drill down to a particular individual item. So for a particular PO, if we want to identify what would happen if for a particular PO in the future, the CPI were to rise by, let's say, 10%. There's various mechanisms out in the world that could end up introducing delays into our system, including repricing of that product, maybe layoffs in a particular region, which will introduce various shipping delays for particular ports. So we can actually run these scenario analyses across different external factors that we might not have control over, but we can see what would happen to our POs in that scenario. And then for the ones that we do identify as particularly problematic, we can actually then do a algorithmic recourse workflow where we find the best course of action, given now that we've identified the particular PO is at risk. We can do this for, again, particular line items, or we can do for entire groups of shipments, for all from a particular supplier, all of a particular item category, so on and so forth. And then I'll actually just briefly show some of our decision apps, which we're going to review in part 2. This includes actually taking the previous model that we looked at, applying our data on top of it, and then we'll actually see in real time what various shipping methods do to our overall delay, and then how over time we can adjust particular factors in order to reduce the variance in that delay, or overall introduce like various mechanisms to decrease our likelihood of having that delay. All right, so delay contribution is another one of those workflows we'll look at in part 2, but I'll just quickly show it here now. Just probably shoot back in like the next week or two, and that'll be up for everyone's review. Thanks, everyone.